Welcome to the HIF cell here in Stuttgart and to H2 International. My name is Eva Augston and I can welcome here Rob Atkinson from Siemens AG. He's the lead of the hydrogen unit within the factory automation, and I'm really happy to have you here.
Wonderful. Happy to be here.
Right. Rob, would you be so kind to introduce a bit how you and Siemens are working for the hydrogen industry? What exactly is Siemens doing in hydrogen?
It's a lot. It is a lot. Siemens is obviously a very large company with a lot of different applications and offerings we can bring to the market. Our three main cores are electrification, automation, and digitalization. And what that means is when it comes to building plants, we can do all the grid controls, bring all the switchgear in to actually bring the electricity to the site. When it comes to an automation solution, it can be from small to large, dependent on the size. We can do small solutions all up to huge chemical plant size automation. And then across everything is digitalization. Digitalization enables us to look at multiple aspects within that value chain for what we're doing. The crux of what we're doing, or specifically what we brought here at HIF Cell, is around manufacturing and looking predominantly at the stacks. How do we actually build the power stacks for fuel cells or electrolyzers? And here we have a manufacturing suite which simulates the entire design process and the build process for building a power stack, which we can then help our OEMs when it comes to building their factories.
So if someone wants to produce a fuel cell or a fuel cell stack, you can help them build it.
Exactly. That's exactly what we try to do.
Okay.
We can help them with understanding how the machines work. We can help them understanding how the materials are going to work, and we can help them actually put together the entire concept, even to the point of looking at the energy management concept within the factory, so they could then take that to work out the product carbon footprint of the product that they are actually producing.
Okay. In the other section, did I understand that correctly, is for if someone wants to build an electrolyzer, so everything that is around the electrolyzer you can get also from Siemens?
Yes, Siemens, we have, I said, switchgear, sensors, small-scale VFDs. There's a lot of individual elements that we can do that. One thing that we've done specifically for electrolyzers on a smaller scale when it's going in containers is a look to create elements within there that are standardized on our automation and have the standardized products from, say, the sensor technology or the VFD technology built in and incorporated into the TIA portal. So it makes the automation design and engineering stage much, much quicker.
Okay, so you got like many more or less standardized units, and you just, like a building kit, you put them together?
It would be very simple to call it Lego blocks, but it is kind of understandable that way, yes. I mean, we have created blueprints and templates within our TIA portal for various applications within the hydrogen ecosystem that can be used to help manufacturers save engineering times and costs. And it's not just for fuel cells electrolyzers, also for filling stations.
Okay.
And that's also something which needs to be built up. We also have design templates in there for filling stations as well.
Okay, so it's electrolyzers, fuel cell factories, filling stations, anything else? Everything?
Well, Siemens, I mean, other than the main three pillars, Siemens also has financing. We have financed hydrogen projects in the past. We will be willing to finance hydrogen projects in the future if the economics look right. We also have consulting. We have a consulting arm, so we can actually help customers who are uncertain about their journey. We can go in there and give them the knowledge of our expertise to help them ascertain what they're doing. So, yes.
Right. And digitalization plays a big role in hydrogen as well, and in anything that's standardized. So well, in everything basically. What is the role of digitalization in your processes?
That is probably the biggest thing at the moment. I mean, Siemens, we make good products. We made good products for years. Everybody knows us for our products. Yes, we do. But I think the differentiator at the moment is digitalization and how we can use the digitalization to help us save costs throughout whatever we're doing in hydrogen. And there are many different examples, starting with the factory. Now, if we look at the factory, we look at the electrolyzer product today, that product has only been commercially viable about 10 years. Now, put that into consideration. Think what the first combustion engine looked like after 10 years, back in the 1800s, and compare that to the version we're driving now in our cars. Well, that's where we are at the moment with electrolyzers. We're in them first iterations. So we are on a very steep learning curve with that product. Now, every time we learn about that product and we change that product, well, we have to change the build process. We have to change the machines in the factory. So if we do a digital twin of the factory now with version 1, and we say, okay, we're changing the membrane because we found a better solution, we can then take that machine out of the digital twin, put the new machine in the digital twin, and run that simulation, run the throughput, see what changes there are. And you may find, okay, the process is many different machines coming together. We say, oh, we changed that machine, but now we have a problem up here. We can't do the stacking properly. And so, okay, we've got now a problem with the stacking machine. Okay, we changed that out. And then you go, oh, we got a problem with the decal. So by doing the digital twin, we can help the customer save time. So instead of just saying we're going to change the membrane, change the machine out, and then a couple of weeks later, oh, we got a new problem. We can look through all them problems ahead of time and then do the digital twin and do all the changes at once.
Okay.
Likewise, we also have the ability within Siemens to our digital offerings to, at a molecular level, look within the power stack, how the gas regulation is doing. We can look at actually how that stack is operating. Again, it's part of that life cycle loop. How do we work out what's going on here? Helps with the iteration moving forward. Furthermore, we can then look at a complete electromechanical system. Say the Messe Stuttgart, where we're sitting today, wants to put hydrogen in place. They've got forklifts. They want to convert it all to hydrogen. Well, we can work out, okay, they can't put a windmill up because there's an airport, but they want to put solar in. They want to put electrolyzer in. They've got X many forklifts, and we know what the fuel cell is in them. Well, we can simulate, okay, we've got these forklifts. That's how much hydrogen we're going to need. Okay, so we'll look at the electrolyzer they want to use. Okay, how much solar do we need to make that use case work? And we look at that entire ecosystem and in a way, de-risk it for the customer.
So you can basically try everything in a digital version without having to throw out like 10 machines because you were trying. And
so much of the problems we're having at the moment in hydrogen is projects aren't moving forward because of risk. People are scared because this is new technology. We're not certain how it works. So we're trying to help people take risk out of the equation. By doing that kind of simulation, you can prove the use case before implementing it. And it's not going to cost you the world to do it. Rather invest 50,000 to 100,000 in the digitalization use case and spend 10 million building a plant which isn't going to work. And so this is how we can help. And then, of course, there's other offerings like our digital hydrogen plant with our hydrogen performance suite. That is then when we start looking at large-scale hydrogen production. How can we then optimize the process? How can we then help our end users work out, okay, we are getting all this power, we have this set up this way. How can we optimize this? How can we actually do fleet management? How can we look at these degradations that we're talking about that we can feed into the models? So it's a whole complete suite of tools that we have for lots of various applications across the entire ecosystem and value chain. So it's a very wide offering.
So basically you got everything once for real and again everything the same time as a digital version.
Pretty much, yes. I said, be it a fuel cell, be it a tanking solution, be it a huge chemical plant going into ammonia. All possible.
And with all that, you can also, I guess, accelerate a lot the development because you do not really have to build and make these mistakes and hopefully take the hydrogen industry a lot quicker to a success than we had from this first cars to what we drive today.
Exactly, and I love the word accelerate. That's a word we use in Siemens a lot. We want to be an accelerator. We want to accelerate the industry, and that's what our tools bring. Our tools bring the ability to create modular solutions, standardized solutions that could be placed in a digital world that can be then optimized and then built, integrated, and delivered.
That sounds really good, and it sounds like something that hydrogen technology really, really needs at the moment. So
I agree.
thank you so much, Rob.
Pleasure. It's a pleasure being here, Eva. Wonderful.
Thank you.